So, as I was saying before, um, when we graph geometric sequences, we get graphs that are called discrete graphs rather than continuous graphs. What that means is that the graphs are not a series of points that are connected in a continuous line where there's a value between every point. We simply get a series of points. So, for example, in our graph over here, we get a series of points on the graph. We do not get a line connecting them. Okay, in order to get that graph, we're just going to take the sequence that we start with, -1, -2, -4. First, we're going to find the common ratio, which just means figure out what we're multiplying by. Well, just looking at these, it's pretty obvious to me that we're multiplying by 2. Now, if the values were not so obvious, once again, the way to do that would be to find the ratio between two terms. So if I divide -4 by -2, I would get 2. If I divide -2 divided by -1, I would get 2 as well. So any two consecutive terms, doesn't have to be the first two, but any two consecutive terms, we find their ratio, and that is our common ratio. Then we can just continue multiplying by that. So we'll get -16, -32 after that, so on and so forth. So I see -32, I see -16, I see -8. I actually see that it looks like the company that put this together didn't get -4 on there correctly. Um, Before that would have been -2 right here. So actually, for whatever reason, those 2 points look a little off to me, but we'll give them a break. They do a good job most of the time. Um, the domain, so the x values that are allowed are 1, 2, 3, 4, 5, 6 in this one when we're looking at the first 6 terms. So that means that the domain is not 1.1, it's not 1.2, it's none of the decimals in between. It is just the integer x values. Okay, so there's just a first term, there's just a second term, there's not a 1.5 term. Okay, in sequences, the x values, the domains are always integers. And then our range are just the values that we're getting out. And that's really all it takes to graph one of these.